Okay, we're going to try another example here. This is going to be an integration by parts integral. So in general, when we look at integration by parts, the example that I have in my notes, for instance, we look for something where its derivative will give us a much simpler integral when we apply the parts formula. But in this case, that's not quite going to work out. However, this is a good example of where experimenting and just kind of going forward, even if you're not sure what's happening, and kind of playing around with the algebra and the tools that we have leads to something good. So I'm gonna look at this. I know that none of the other techniques we have so far are gonna work. There's no good substitution to make that I can see. So let's go ahead and just try parts and see what happens. So I'm going to choose u to be e to the negative x, which makes du negative e to the negative x dx. I'll choose as dv cosine of x dx, which means v was sine of x. Right? And so now I'm using the parts formula. We take u times v, so e to the negative x sine of x, minus the integral of v du. So I'll have e to the negative x with a negative, so I'm just going to absorb that negative into the negative in the formula to make it positive. So I have an e to the negative x, there's a dx, and I get sine x from v. So I'm just putting the dx at the end. That's sort of the most pleasing way to write it, subjectively. So what we ended up with is this, right? This part's sort of out of the integral. This part is another integral, but it's not really any simpler than what we have here, which might be a sign to say, all right, this isn't working. However, this is an example of where something turns out, something kind of clever turns out. So let's look at this integral right here for a minute. Let's just focus on that. E to the negative x sine of x dx. And let's do the exact same thing, or almost the exact same thing here. Let's do integration by parts just on this integral. We get u equals e to the negative x. Du is negative e to the negative x dx. dv will be sine of x dx, which means that v must be negative cosine of x. And again, I just apply the parts formula. U times v, so I get a negative e to the negative x cosine of x, minus v du. Let's make this clearer. That's a u. V du. Notice I've got a negative already here. We're going to have minus the integral of v times du. I'm going to pick up another negative here and another negative here. So we'll have a negative, a negative, a negative, which means we'll end up with a negative. And then we'll have our e to the negative x cosine of x dx. So I'm putting in the v and the du. So I get e to the negative x cosine of x and dx. And the negatives combine to leave us with a negative there. Okay. Now, again, it seems like nothing useful happened, right? We still end up with another integral that's almost like what we started. But one thing we can notice is that's exactly the same integral that we began with. Okay. So let's put this together. So starting from here, right? Let's start from here. I have the integral of e to the negative x cosine of x dx equals, we didn't do anything to this, e to the negative x sine of x. And now this integral here, right, we worked out is equal to this down here. So we're going to put this all in place of that right here. So I get minus e to the negative x cosine of x minus e to the negative x cosine of x dx. Okay, so now we're just going to use algebra. I'm going to add this integral to both sides. Okay, so there's a lot of notation happening here, but what's happening over here is we've got a thing, and we're adding the same thing to it. So when you take a thing and add itself to it, you just get two of that thing. All right, so now we have two of those integrals. And on this side, all that's left, so I get a negative of a thing and a positive of the same thing, those cancel out, and I'm left with just this, e to the negative x. Let's just factor out the e to the negative x times sine of x minus cosine of x. Okay? And so now my last step, divide both sides by 2. I end up with, or let's just write it as multiplying by 1/2 sine x minus cosine of x, and then I'll add a constant of integration. Okay? And so this is a neat little trick. It always feels to me like we never actually took the integral, right? We kept getting integrals that we didn't know what to do with, and we used parts. But somehow the algebra conspired so that we still got something on this side without an integral, right? And so this is our general antiderivative for this function. And I'll leave it up to you guys. I've checked it myself, but I think it's a good exercise to remember our derivatives. Take the derivative of this, and you'll find that you do get exactly this. So this is truly an antiderivative of that function.